Hi, this session is on multiples. We'll understand what multiples are and how to work with multiples, and also finding the lowest common multiple. Okay, let's make sure we understand what multiples are. The word multiple, you can almost see multiplication in there. So when you see the word multiple, think of multiplication, because that's what we're doing. We're working with multiplication. Now, multiples are the products or answers when a number is multiplied by other numbers. So product is a key word you'll be seeing in maths, and whenever you see the word product, you also think of multiplication. Okay, and they are the answers when we multiply numbers. Now, when it comes to multiples, there are an infinite amount of multiples. Infinite means never ending, so just keep that in mind as well. Now, let's look at an example. So the example here says a multiple of 2 is 10 because if I go 2 times 5, I get a product, an answer of 10. Okay, so my number that I'm working with is 2. So if I get my number 2 and I multiply it with other numbers, so think of your timetables. Here's my 2 timetables. I'm multiplying 2, in this case, by 1. So 1 times 2, 2 times 2, 3 times 2. So all of these numbers here, the products column, are multiples of 2. Okay? And another way of looking at it is we can just count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, and it keeps on going. Yes, our timetables usually stop at 12, our 12 timetables is what we learn, but we can keep going. Can I go 2 times 13? Yes. And 2 times 14, 2 times 15, it's never ending. Okay? But multiples are the answers, the products, and that's what they are. So, you may have played the game Snail Trail before. To play this game, if I ask you to write multiples of a number, just say 2. When I say go, write it down as fast as you can, the multiples of 2. So in this case, we start with 2 and then go 2, 4, 6, 8, and you keep on going. So for example, multiples of 3, you would write 3, 6, 9, 12, 15, 18, and keep on going until I say stop. Okay? So if you've played that game, always think of Snail Trail. Another way to calculate multiples is to keep adding the same number. And we'll look at this and apply this in some examples, because sometimes we don't just work with timetables. What if I asked you what are the multiples of 51, just say? Now, I don't know my timetables for 51, but there is another way to work out multiples. Okay, let's try this example. Write down the first 6 multiples of 3. Please have a go first. Okay, so for our first example, I need to work out the first 6 multiples of 3. Now, if you're confident with your timetables, you would go, okay, start with 3. Always start with the number itself and go 3, 6, 9, 12, 15. How many do I have? 1, 2, 3, 4, 5, and one more, 18. So I just counted by 3s. The other way of doing it is, okay, what if I decided to go, okay, 1 times 3 is 3. There's my first multiple. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. 5 times 3 is 15. And 6 times 3 is 18. So my products are my multiples, just here. So the first 6 multiples of 3. 1, 2, 3, 4, 5, 6. So I multiplied them. Another approach is just say somebody didn't know their 3 timetables, which is fine. So we know we have 3. So to work out multiples of 3 without any timetable knowledge is just keep adding the same number. So I'm working with 3. So what is 3? I'll do a little arrow up there. Plus 3. Well, 3 plus 3 is 6. And then keep going. Keep plussing 3. What is 6 plus 3? 9. What is 9 plus 3? 12. What is 12 plus 3? 15. And one more time. 15 plus 3, we get our 18. 1, 2, 3, 4, 5, 6. Okay, so sometimes different strategies might be useful for different types of problems. With this one, most of us are pretty confident with our timetables, so just counting by 3s until you get 6 numbers, okay, or 6 products. For our next example, it asks us to write down the first 5 multiples of 21. Now 21 is getting larger, and you may not be able to calculate it just by counting by 21s, so try and pick a strategy that might work for you. Okay, so multiples of 21, I need the first 5. So I'm going to start with 21, that's my first multiple, because 1 times 21 is 21. Now I'm just going to keep adding 21. So I might actually go this way, because I can add them using my addition skills, and it's sort of already like an algorithm. What is 21 plus 21? Well, I have 1 plus 1 is 2, and 2 plus 2 is 4. So my next multiple is 42. So just over here, I'll do my answer up here. So 21 is the first multiple, then 42, and I'll keep adding 21. So now I'm at 42. What is 42 plus 21? Well, 42 plus 21, 2 plus 1 is 3, 4 plus 2 is 6. So my next multiple is 63. So you can see I'm just counting by 21s. If I don't know them mentally, that's okay. I'll just keep adding 21. Alright, and add 21 again to 63. 3 plus 1 is 4, 6 plus 2 is 8. So 84. And one more time, because the question asks us to find the first 5 multiples. Sorry, I'm going at an angle. Alright, so I've got 4 plus 1 is 5, 8 plus 2 is 10, and I've got 105. Now let's just count. 1, 2, 3, 4, 5. These are the first 5 multiples of 21. Okay, now that we know what multiples are and how to work out multiples for a particular number, we're going to look at finding the lowest common multiple, or for short, LCM. Okay? So we know what the word common means, what they have in common, what's similar between them. Okay? And this is also known as the lowest common denominator. You may have heard this when working with fractions. So we're doing the exact same thing. Okay? Now, how to find the lowest common multiple. So have a read through this first, and then we'll follow some of these important steps and tips to work it out. Okay, so I'll use the example we just had before. What is the lowest common multiple of 8 and 12? So when you have a question like this, the first step is to write some numbers, some multiples of each number. Now, I like to start with my larger number first. You don't have to, but because it's larger, we're going to be getting larger values quicker, which means we might see something in common sooner. So I'll explain that in a minute. So what are multiples of 12? I might write maybe the first 4 or 5 multiples, because 12 is getting quite large. So first one's there, so 12 plus 12, or 12 times 2, is 24, plus 12, or this time times it by 3. So you work it out whether you know your 12 time tables or you're confident with adding 12. Okay, so 24, then I'll have 36. 36 plus 12. I have my 48. And I've got 4 multiples. Now I might stop there and see if 8 will have, the multiples of 8 will be in common with any of these. So they're multiples of 12. So multiples of 8, I'll just write underneath. We can see the ascending order from smallest to largest. So 8. Now, 8 plus 8 gives me 16. 16 plus 8 gives me 24. 24 plus 8 gives me 32. Now, I will stop there and compare. Do you see any multiples that are common between 12 and 8 right now? Well, I can see a common multiple between them is 24. I can see a 24 here and 24 there. Now, if I look below 24, I've got a 12 here, but I don't have a 12 as a multiple of 8. The next one is 16 here, so there is nothing else that is common, nothing else that is smaller than 24, okay, as a common multiple. We might come across some more common multiples if we kept going. That's okay, we want the lowest one. So the lowest one has to be 24 because we started writing this in ascending order. So my final answer would be the lowest common multiple is 24. Okay, that's what they both have in common. Okay, for our next question, It asks us to find the lowest common multiple of 2, 5 and 10. So now we're working with 3 numbers. Now remember to please have a go first. Write the question down and have a go. So what is the lowest common multiple of 2, 5 and 10? Well, I will start with my my largest number here, which is 10. If you started with 2 or 5, that's fine. I just like to start with my largest one. Then I'll find multiples of 5 and multiples of 2 and see which one all 3 have. That's the lowest one. So multiples of 10, 10, 20, 30, 40 and 50. Now I might stop there because 2 is a smaller number, and maybe that will be enough to see a common multiple between all of them. Now multiples of 5, 5, 10, 15, 20, 25, and multiples of 2, 2, oh sorry, I already have 2 there, 2, 4, 6, 8, and 10. Okay, so if I have a look, what are some common multiples that you might see between 10, 5 and 2? I can see one standing out, and that is 10. I can see a 10 here. 10 is a multiple of itself, it's fine, and there is a 10 over here as well. Okay, so we can see a common multiple between 10, 5 and 2 is 10, and that is the lowest one. Now if I kept going with my 2's, just say I said okay, 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. We can also see another common multiple. Okay, I can see I have 20 over here, 20 over here with my 5 multiples of 5, and then 20 is a multiple of 2 as well. Okay, now that is also a common multiple, but remember we want the lowest common multiple, and like I said before, this skill is important when finding the lowest common denominator. Okay, so yes, there are many common multiples between numbers. We want to find the lowest one. That's why when you're doing this, write in ascending order from smallest to largest for each number, and then once you see a number that all of them have that's common, you can stop.